Okay, let's unpack this. So for the last deep dive, we really immersed ourselves in the gritty mechanics of lexical scope, where variables live, how JavaScript finds the...
Right, the nuts and bolts.
Exactly. Now, we're kind of leveling up. We're moving from just understanding how it works mechanically to, well, the strategy behind organizing our programs using scope.
That's a really critical shift, yeah. We're moving from observation to application. Our mission today is really to codify the rules, find those proven patterns that guide us when we're organizing code.
Specifically around choosing function scope, using var versus block scope with let or const, right?
Precisely. And the whole thing, the overriding objective, is about reducing unnecessary scope overexposure, keeping things tidy, basically.
Okay, and this whole strategy, you mentioned it rests on a concept borrowed from software security.
That's right. The principle of least privilege, or POLP. You hear this a lot in security circles.
Yeah, the idea that components or users, whatever, should only have the absolute minimum access they need to do their specific job. It's like fundamentally defensive.
Exactly. It's a security posture. And we apply a kind of variation of that directly to our variables. We call it the principle of least exposure, or POL.
Poly.
Yeah. So if least privilege protects systems from, say, hackers, payload protects different parts of your code from interfering with each other, the goal is to minimize the visibility, the exposure of any variable in any given scope.
It seems obvious, like intuitively wrong to just dump everything in the global scope. But Pele gives us the why, doesn't it? What are the specific dangers it points out when you expose variables too much?
Well, Pele identifies three main hazards, three really destructive ones.
Yeah.
The first one is probably the most immediate, the one you bump into first, naming collisions.
Oh, right.
If a variable is exposed too widely, like globally, then different unrelated parts of your program might accidentally try to use the same common name. Think about the classic loop index I.
Oh, yeah. Everyone uses I.
Exactly. So if two different functions both start loops at the same time and they both rely on the same global I, they're just going to stomp all over each other's values. Instant bugs. Unpredictable ones.
That makes total sense. Okay, what's the second hazard?
The second one is more about potential misuse. We call it unexpected behavior. If you expose an internal variable, let's say you have an array inside your component, and you assume it's always going to hold just numbers.
Right, because that's all your code puts in it.
Exactly. But if it's exposed, some other developer, maybe even some external script, could come along and push a string into it or an object. Suddenly, your component starts throwing errors or behaving weirdly because its fundamental assumption about its own private data got broken.
Okay, so it protects the integrity of a component's internal state.
Precisely. And the third hazard, this one is often the sneakiest, the biggest long-term killer. Unintended dependency.
Unintended dependency.
Yeah, it's subtle. If a variable is exposed unnecessarily, even if it's just an internal implementation detail of your component, other parts of the system might start, well, depending on it, even if they shouldn't.
How so?
Let's say you expose your internal caching mechanism. Maybe it's an array. Someone else writing another part of the system sees it, thinks, oh, useful, and starts using it directly. Years later, you need to refactor your component. You decide to swap that array out for, say, a map for better performance.
And suddenly you break like 5 other parts of the system you didn't even know were touching your internal stuff.
Exactly. You're completely stuck. Or you cause widespread breakage, all because that internal detail wasn't properly hidden.
Wow. It's kind of amazing how just deciding where to put one little variable can ripple out like that over time. So PL is basically saying default to private, hide everything unless you absolutely must expose it.
That's the core posture. Keep everything as private, as hidden, as minimally exposed as possible. Let's look at a concrete code example they give. A simple function, defects x, y. It just calculates the absolute difference between two numbers.
Okay.
Inside, there's an if block. It checks if x is greater than y. If it is, it needs to swap x and y, so it can just do yx. And it uses a temporary variable, tmp, to do the swap.
Right. The classic 3-step swap. Now, in older JavaScript, you might see vartemp declared way up at the top of the diff function. But applying PBOLA, how should we handle temp?
Well, you ask, where is temp actually needed? Only inside the if block, right, for just those 3 swap statements.
Yeah, nowhere else.
So PLE dictates we should declare it right there, inside the if block, using let temp. By using let, temp becomes block scoped. It literally pops into existence only when that if block starts, does its job, and then disappears the moment the block ends.
It never even existed in the main scope of the diff function, let alone globally.
Exactly. Minimal necessary exposure. That's POA in action.
That really shows the power of let and block scoping for keeping things tight. But okay, now we have the flip side. What about function scope, where var traditionally lived? What if we need a variable to hang around to maintain its state across multiple calls to the same function?
Right. If we put it inside the function with let or even var, it gets reset every single time the function is called.
Yeah, that doesn't work for things like caching or stateful operations.
Exactly. And this brings us to a really classic pattern for solving this. The need to create a sort of hidden middle scope, a scope that holds the state but protects it from the outside world. Think about calculating factorials, like 7 factorials.
Okay, factorial x.
We want that function to be smart. If we calculate factorials, we want it to remember that result. So if we immediately ask for factorial 7, it can just take the result for 6, multiply by 7, and be done much faster. It needs to cache results.
So it needs a cache variable, maybe an object or a map. If we make cache global, well, we just talked about why that's bad. POE violation.
Right. But if you put var cache inside the factorial function itself,
It gets wiped clean and reset to an empty object every single time you call factorial. The caching is useless.
precisely. So the solution is what's often called the hiding wrapper function pattern. We define a new outer function. Let's maybe call it make factorial function.
Okay, a function factory,
Yeah.
sort of.
Kind of, yeah. Inside that wrapper function, make factorial function, we declare var cache. And also inside the wrapper, we define the actual recursive factorial function which uses that cache.
Ah, so cache is local to the wrapper.
Exactly. And here's the crucial part. The wrapper function, make factorial function, returns a reference to the inner factorial function. It doesn't return the result, it returns the function itself.
Okay, so when I write something like let my factorial make factorial function, I'm executing the wrapper.
You execute the wrapper once, it sets up the cache, it defines the inner factorial function, then the wrapper finishes executing. But because the inner factorial function that got returned still needs access to that cache variable from its surrounding scope.
JavaScript keeps that wrapper scope alive, even though the wrapper function is finished running.
Exactly. That scope, with the cache inside it, persists in memory. It's hidden from the global scope, totally private, but the inner factorial function we're calling myFactorialX can still reach out and use it every time. State persistence without global exposure.
That's clever. That's the core formalism.
It is. But, you know, naming these wrapper functions all the time, like make factorial function, can get a bit tedious, especially if you only use them once.
Right, it adds clutter.
So developers quickly refined this. They started using a function expression for the wrapper instead of a function declaration.
Okay, why the expression?
Remember how function declarations like function make factorial function have their name hoisted and added to the surrounding scope?
Yeah, that could cause naming collisions itself, which goes against PL.
Exactly.
Yeah.
But the name of a function expression like let make factorial function the inner name, that inner name, the inner name, is only scoped inside the function expression itself. It doesn't pollute the outer scope.
Okay, cleaner.
Much cleaner.
Yeah.
So you take that function expression, you wrap it in parentheses to tell JavaScript, hey, treat this definitely as an expression, not a declaration.
Okay.
And then you immediately call it, right after the closing parentheses, with another pair of parentheses. That's the one. The immediately invoked function expression, or IIFE, pronounced IFE.
Right, heard of those.
It does the whole pattern in one go. It creates the function expression, instantly executes it, sets up the hidden scope, like our cache, returns whatever inner function or value you need, and does it all without leaving any temporary wrapper function name behind in the outer scope.
Instant hidden scope. Very neat. But you mentioned there's a catch, a potential pitfall with IIFE.
Yes, a really important one. Because an IIFE is a function, it creates a full function boundary. This changes how certain keywords behave if they're inside the IIFE.
Which keywords?
Things like return, this, break, and continue. If you use, say, return inside an IIFE, it returns from the IIFE function itself, not from the outer function or block where the IIFE happens to be placed. Same idea for this binding, or trying to break out of a loop that surrounds the IIFE.
Ah, okay. So if the code you're wrapping in an IIFE relies on those keywords affecting the outside code, then an IIFE is the wrong tool for hiding scope.
Absolutely. It's great for creating that persistent hidden state scope, but not for just wrapping arbitrary blocks of code that need to interact directly with their surroundings via those keywords.
Okay, so IIFEs are for hiding persistent state using a function boundary. What about hiding variables that are just temporary, like that TP variable in the diff example? We used let there. That brings us back to block scoping, right?
Precisely. We know let and const give us block scope. And remember, a pair of curly braces is a block. It only becomes a scope, though, if it actually contains a block scope to declaration, let or const.
So we can use curly braces just on their own, not just with if or for.
Yes. And this gives us a really powerful fine-grained tool, explicit standalone blocks.
Just loading in the middle of some code.
Exactly. You use them purely to carve out a very narrow, very specific slice of scope, just for one or two variables, strictly following Pili.
So let's say I have that if statement again, but maybe I only need a temporary variable for the first couple of lines inside the if.
Then, instead of declaring it with let at the top of the if block, you could wrap just those first two lines inside another inner pair of curly braces and declare the let variable inside that inner block.
Wow, okay, so you minimize its exposure even further. It only lives for those two lines.
Exactly. Super precise scope control. And this actually connects back to something we mentioned earlier, the temporal dead zone, TDZ.
Right, with let and const, you can't access the variable before its declaration.
Yeah. And the common advice is put your let declarations at the very top of their scope, be it function or block, to avoid accidental TDZ errors. Make them available right away within that scope.
Okay.
But if you find yourself thinking, I don't actually need this variable until way down here in the middle of the block, and you're tempted to declare it later, that should be a signal.
A signal that. Okay.
Signal that your current scope is probably too wide for that variable. If you don't need it at the top, it probably doesn't belong to the whole block.
Ah. So instead of just declaring it later in the same block, I should probably create a new inner explicit block scope right where I need it, declare it there, use it, and let it disappear immediately after.
That's the Pili thinking. Keep the scope as small as possible, as close to the point of use as possible. Look at the get next month start datester example they discussed.
Okay, what's the structure there?
It needs to figure out the date for the start of the next month. It has variables like next month and year, which are needed for the final result, so they're function scoped declared at the top. But to calculate those, it first needs to parse the current month, let's call it cur month, from the input date string.
And that cur month is only needed temporarily for that calculation part.
Exactly. It's just an intermediate value. So instead of cluttering the main function scoop with let cur month, the example wraps the two lines that parse and use cur month inside an explicit block. Let cur month is declared inside that block.
So once next month is calculated using cur month, that inner block ends and cur month just vanishes.
Precisely. Surgical scope minimization. That mindset, always asking, can I make this scope even smaller? That's the key takeaway for PLE strategy.
Okay, this is making sense. Now let's tackle the thing that often trips up developers or starts arguments, the var versus let choice. We saw the sort names by length example where buckets, an array, is declared with var buckets at the top of the function.
Right.
If let is generally preferred now for block scoping, why would the source material argue for keeping var for function scoped variables like buckets?
This really dives into a stylistic, almost semantic argument. Historically, before let existed, var always signaled function scope no matter where you physically typed it in the function because of hoisting.
Okay, it meant belongs to the whole function.
Exactly. So the argument presented is that continuing to use var, but only at the top level of a function, provides a clear visual signal to someone reading the code. It says this variable, buckets, is intentionally function scoped. It's needed throughout this function.
Whereas using let or const immediately signals this variable is block scoped, its life is limited to this specific block.
That's the idea. It uses the choice of keyword to communicate the intended scope of the variable.
Now, I know the general consensus you often hear is just ditch var completely. Use let and const for everything.
Yeah, that's a very common viewpoint. But the position in this source material is a bit more nuanced. It argues that using both keywords, purposefully var strictly for function level scope declared at the top, and let const strictly for block level scope declared where needed, actually provides the clearest, most readable communication of your scope strategy.
So it's about maximizing the semantic meaning of the keywords themselves.
Exactly. But crucially, the decision process doesn't start with the keyword. It always starts with PL. You first ask, what is the absolute smallest, most minimal scope this variable needs to exist in?
Okay, determine the necessary scope first.
Right. Is it the whole function? or just this if block, or just these two lines inside the if block. Once you've decided the minimal scope, then you choose the keyword that achieves that scope. Var for function, let const for block.
That makes sense. So for a standard for loop index?
The index I is only needed inside the loop block. Poll demands block scope, therefore the standard should always be for let I equals 0.
What about that old pattern where people used var I and then needed the final value of I after the loop finished?
That's now considered kind of smelly code because it relies on the overexposure that var I created. The Pele-friendly way is clear. Use let I inside the loop for the iteration itself, keeping it block scoped. If you genuinely need the final value or some value derived from a loop outside, declare a separate, appropriately scoped variable, maybe a function scoped var last result outside of the loop, and assign the needed value to it from within the loop.
So you separate the temporary loop mechanism from the persistent result you need.
Exactly. Keep concerns separate, keep scopes minimal.
Okay, nearly there. We need to hit two quick edge cases mentioned. First, the catch clause in try.catch.
Right. Minor point, but good to know. The error variable you declare, like error in catch error, is block scoped specifically to that catch block.
Okay, that seems logical.
But here's the quirk. If you declare a variable using var inside the catch block, that var declaration still hoists and attaches to the outer function scope, not just the catch block. It's a bit weird.
Huh.
Also worth noting, since ES 2019, if you don't actually need the error value inside the catch, you can just omit the error part entirely and write catch handle error, which is nice. Simplifies things, removes an unnecessary variable binding.
Good tip. And the final really big warning area, function declarations in blocks, or fib.
Ah, yes, fib. This is a major source of headaches and inconsistency. What happens if you put a standard function declaration like function ask directly inside an if block or a for loop block?
What should happen versus what does happen.
Well, according to the modern JavaScript specification, that function declaration should be block scope, just like let. Trying to access ask outside that block should fail.
Right.
But historically, different JavaScript engines implemented this differently, especially in non-strict mode. Some would hoist it to the function scope but initialize it as undefined. Some might scope it differently based on strict mode or not. It was, frankly, a mess.
So different browsers or Node.js might behave differently with the exact same code.
Yes. Highly inconsistent and unreliable across environments. Because of this deep-seated historical variance.
The advice is just don't do it.
Pretty much. The strong practical advice is avoid fib entirely. Never, ever place a standard function declaration directly inside any block, if for a while, even just an explicit array.
Okay. What if you do need to define a function conditionally? Like only define ask if a certain condition is true.
Use a function expression instead. Assign it to a let or var variable. Function expressions inside blocks behave predictably and follow standard scoping rules. So, if condition ask is perfectly fine and safe, just avoid the function ask. Declaration syntax inside blocks.
Got it. Declaration bad, expression okay inside blocks.
You got it.
Okay, let's try to wrap this all up. We've covered a lot about scope strategy. The core idea seems to be that using lexical scope effectively is all about organizing your code for clarity, maintainability, and security in a way.
That's a great summary. And the driving philosophy behind that organization is the principle of least exposure pull. Make sure no variable is visible or alive for longer or in a wider scope than absolutely necessary.
And the main tools we have for achieving this are IEs, for creating those hidden persistent scopes often used for state.
Right, using function scope boundaries.
Explicit block scoping, using with let or const to create really narrow temporary scopes.
For surgical minimization.
And maybe even the semantic use of var at the function top level versus let inside blocks as a way to communicate intent.
Exactly. Using the keywords to signal the chosen scope. We now have a really solid strategic foundation for how to structure our code and hide our data effectively.
We know how to control how long a variable stays hidden, how wide its scope is.
Which leads us to a really interesting, kind of mind-bending question to leave you with. If we can design a function, maybe like our factorial example, specifically so that it maintains access to variables from its outer scope, even after that outer scope has technically finished running,
Right.
What do we call that incredibly powerful mechanism?
That phenomenon, listeners, is known as closure. And it's the fundamental concept we'll be diving into next time. Thank you for joining us for this deep dive into JavaScript scope strategy.